We're going to start looking at recurrence relations. Now, recurrence relations are a way of describing a sequence of numbers like 3, 5, 7, 9, and so on. Recurrence relations use the previous term to describe or calculate the next term of a sequence. Now, every sequence has a given starting or initial value, and we're going to call this value u subscript 0. And that will initiate, or that will signify our initial value. So you'll notice that when dealing with recurrence relations, we're using these subscript numbers to identify the terms. So instead of just term 1, we say u1. Term 2 would be u2, and so on. And then our nth term, or the term way down the line that we're not sure, would be un. So that's what we're using as our notation for our recurrence relations. Now, the next term is the current term plus 5. So if you notice, we're adding 5 to each of these. So we look at this in recurrence relation notation. We're taking u, n plus 1. So to get the next term, we take the current term, u of n, and we add 5. Or, another way to look at it, the current term is the previous term plus 5. So we can also see it like this. So the current term, which is un, is the previous term, so un minus 1 now, so the term before, plus 5. So you'll see it can be written both these ways, and you have to be able to interpret what it's asking you. So if we look at this here, a recurrence relation describes a sequence in which each term is a function of the previous term. So a linear recurrence relation is defined by this. This is your general formula or format for a recurrence relation. So here we know we're looking for the next term based on the current term. And this is where the A and B are values, right? But A cannot be 0. So here un plus 1 is the next term. Un is our current term. A is going to be our multiplier. And B is just a term you're adding or subtracting. Or, again, looking at the other way, it can also be written as the current term based on the previous term. So here we have un is my current term, and un minus 1 is my previous term, and again, A is still my multiplier, and B is just my addition and subtraction. So let's look at an example. So we know a recurrence relation is a way of describing a problem which has a reoccurring feature. But an example of this is adding 4% interest to £1,000 for a 6-year period. Now, we know how to do this, so let's take a quick look. We know we're starting with £1,000, and then with our first year, so after our first year, we know we're increasing, so we have our £1,000 and we're adding 4% interest to that. So remember, to find our interest, we start with 100% of the value and you're adding 4% on, so you end up with 104%. So here, you're going to be multiplying by that 104%, which takes the initial value and adds on the 4. And this will be your multiplier, 1.04. So it's the percentage as a decimal. And when you work that out, you get 1,040. Then to get the next year, we take our value from the end of year 1, so 1,040, and we multiply it by 1.04. And we get 1,081.60. And then you just repeat for all 6 years. Times by 1.04. And we know we do this all the way for year 6. Now, when we're looking at this as a recurrence relation, we know we're using U subscript 0 to stand for the initial value. So our initial value of 1,000 would be U0. Therefore, the first value after this is U1. So if U0 is 1,000, then U1 is going to be our 1.04 times our 1,000. So this is U1. This would be U2, U3, and so on. So when we look at this, we noticed and we know that we're multiplying by 1.04 every time. So the recurrence relation for the sequence can be written as, to get the next term, you're going to take 1.04, your multiplier, and multiply it by your previous term, or your current term. Sorry, your current term. So again, if we look at the very bottom here, so the recurrence relation for the sequence can be written by un plus 1 equals 1.04 un, where un is the value after n years. Okay, so our current value. And un plus 1 is the value after n plus 1 years, our next value.